You're telling me we might find alien life in a hidden ocean, in the air of a planet light years away, or in a radio signal that should not exist, and somehow we still have zero proof. So are we actually close to finding aliens, or are we just alone in the universe? Europa and the moons that broke the old rules. For a long time, people treated life like it needed a pretty normal setup. Rocky planet, right distance from its star, liquid water on the surface, nice little Goldilocks zone situation, not too hot, not too cold, just right, clean, simple, comforting. Then the outer solar system showed up and absolutely wrecked that whole idea. Europa, a moon of Jupiter, is covered by an icy shell, but under that shell there may be a deep liquid ocean, not a puddle, not some seasonal melt, an actual ocean under ice. Enceladus, one of Saturn's moons, is even crazier because it's literally blasting water-rich material into space through giant jets. And Titan, Saturn's largest moon, has rivers, lakes, clouds, and rain, except the liquid on the surface isn't water, it's methane and ethane. So now the old idea that life only belongs on Earth-style planets is starting to look way too small. And this is where the whole conversation gets spicy, because if life can exist in these brutal, weird, freezing places, then maybe life doesn't just show up on calm beach vacation planets. Maybe it's tougher than that. Maybe it can happen in places we used to write off completely. Europa and Enceladus in particular changed the game because they suggest you don't need sunlight hitting the surface to keep water liquid. Tidal forces, basically giant worlds flexing and heating their moons from the inside, can do the job instead. That means the universe may have way more habitable real estate than we thought. Suddenly the search area didn't just get bigger, it exploded. And Europa is maybe the biggest tease of all. Its ice may preserve clues from the ocean below. Radiation at the surface can create compounds like oxygen and other chemically useful stuff that could potentially get cycled into the ocean. In other words, Europa might not just have water. It might have an energy-rich chemical system that life could actually use. Which brings us to the really wild part. If life did start there independently, not seeded from Earth, not borrowed, but started there on its own, that would be a second Genesis in the same solar system. And if life happened twice in one solar system, then you're not looking at a miracle anymore, you're looking at a pattern. We only know one planet with life, and that's a problem. Here's the annoying truth. We talk about life in the universe like we know how it works. We do not. We've got one example, Earth, that's it. And Earth is weird because life here started relatively fast in geological terms, but complex life took forever. The first simple life appears early, then for more than 2 billion years, it's basically microscopic. No cities, no forests, no animals, no anything you'd point to and call dramatic, just tiny cells doing tiny cell things for an unbelievably long time. Then way later, complex cells show up. Later still, multicellular life appears. Then the Cambrian explosion hits, and suddenly evolution starts cooking. That timeline matters a lot, because if simple life is common, but complex life is ridiculously hard, then the universe might be full of microbial slime and still basically empty of civilizations. That's one of the reasons the Fermi Paradox hits so hard. Maybe life itself isn't the rare part. Maybe the rare part is life staying stable long enough on the right planet under the right conditions for billions of years without getting wiped out, frozen over, boiled away, poisoned, smashed by impacts, or trapped forever as pond scum. That's a much darker answer, because it means the universe could be alive and still feel silent. And it gets even messier when you ask what life even has to be. We assume carbon chemistry, water, DNA, cells, membranes, metabolism, all of that. But that's us. That's Earth. Titan's methane lakes raise a question that scientists still can't answer cleanly. Does life absolutely need liquid water, or does it just need a liquid medium and a way to move energy around? Nobody knows. Carbon is great for complex chemistry, sure. Water is an incredible solvent, absolutely. But the deeper we look, the more the universe keeps telling us that our local version of biology might not be the only version possible. So imagine hunting aliens when you don't even know the full shape of what you're hunting. Yeah, good luck with that. What if Earth really is rare? This is where the rare Earth idea walks in and ruins everybody's day, because maybe the reason we haven't found anything is not because we're looking badly. Maybe it's because there just isn't much to find. A planet being Earth-sized is not enough. A planet being in the habitable zone is not enough. You might need liquid water and exposed land. You might need long-term climate stability. You might need plate tectonics, recycling material, and helping regulate the atmosphere. You might need a strong magnetic field to protect the surface. You might need the right kind of star, not too violent, not too young, not too old. You might need the right place in the galaxy, not too close to catastrophic radiation events, not too far from the heavy elements needed to build rocky worlds. You might need a solar system architecture that reduces constant impacts. You might even need weird lucky accidents, like a giant moon stabilizing your planet's tilt over immense spans of time. And then there's the part people forget: water and land together might matter. A full ocean planet sounds cool until you realize technology underwater is a nightmare. Fire is a problem. Advanced chemistry is harder. Metalworking is basically a cosmic joke. So if life spends billions of years in the ocean and never gets a serious push onto land, maybe intelligence never becomes technology. Maybe there are entire alien biospheres out there that are rich, beautiful, and forever pre-industrial because the world itself never gave them a way out. That's brutal, because it means life could be out there and still never talk back. Then the exoplanets arrived and changed everything again. Up until the 1990s, planets around other stars were basically something people assumed had to exist but couldn't prove. Then 51 Pegasi b showed up in 1995 and kicked the door open. This planet was not an Earth twin. It was a hot giant in a place nobody expected a giant planet to be, which was the first clue that the universe was not going to follow our neat little solar system blueprint. Planets migrate, systems get weird, our home setup may not be normal at all. Then came the methods that let us stop guessing and start counting. Radial velocity measures a star wobbling because a planet's gravity tugs on it. Transit detection watches a star dim a tiny bit when a planet crosses in front. That second method was huge because once you see repeated transits, you can estimate the planet's size and orbit. Pair that with other measurements and you start getting mass, density, and the first serious clue about whether the thing is rocky or gaseous. This is where the alien search stopped being pure imagination and became a data problem. Kepler pushed that revolution into overdrive. It stared at around 150,000 stars looking for tiny dips in brightness, and it turned the galaxy from a blank wall into a crowd. Suddenly there were thousands of planetary candidates, then confirmations, then a whole census telling us planets are everywhere. Not rare, not exotic, just everywhere. Kepler didn't prove life exists, but it did destroy the old excuse that maybe Earth was the only place nature bothered making worlds. There are more planets than stars. Let that sink in. The universe is absolutely not short on real estate. We've already found planets that look almost rude. Kepler 186f was a big moment because it was the first validated Earth-sized planet in the habitable zone of another star. It orbits every 130 days and gets about 1/3 the energy Earth gets from the sun, putting it near the cooler outer edge of its system's habitable zone. Kepler 62e and 62f push things further, with models suggesting one could be warm and humid and another cooler, but still potentially friendly to life. Then Kepler 452b showed up, orbiting a star similar to our sun, with a year only about 20 days longer than ours. That one hit especially hard because it felt like Earth had finally seen a cousin. And then there's TRAPPIST-1, a system around a tiny ultra-cool dwarf star about 40 light years away. These stars are dimmer, redder, and way smaller than the sun, which weirdly helps us, because when an Earth-sized planet passes in front of a small star, the signal is easier to catch. That made TRAPPIST-1 one of the best laboratories we've ever found for searching for atmospheric clues. So the question stops being, can planets like Earth exist, and becomes, how many good targets can we check before one of them gives us something undeniable. But don't get ahead of yourself. Finding a rocky world in the habitable zone is not the same as finding life. Not even close. A planet can be the right size in the right orbit, and still be a dead rock with a garbage atmosphere and zero biology? This is where a lot of public alien hype goes off the rails. We found candidates, not confirmation, possibilities, not proof, and that distinction matters because the universe loves making things that look promising from far away and disappointing up close. So how do you actually check? That's where things get insane. James Webb is trying to read alien air. This is probably the coolest part of the whole story. We now have telescopes that can analyze the light passing through the atmosphere of a planet light years away, not by seeing the surface directly because the star is way too bright for that in most cases, but by watching what light goes missing when the planet crosses in front of its star. Certain molecules absorb specific parts of the light, so when Webb looks at that filtered starlight, it can search for what one scientist compared to passport stamps, little fingerprints left by molecules in the atmosphere. And the biggest fingerprint we know for life on Earth is the combination of oxygen and methane in the same atmosphere with water present on a planet in the temperate zone around its star. Why does that combo matter? Because oxygen and methane don't like coexisting for long. If they're both there in strong amounts, something has to keep replenishing them. On Earth, that something is life. So if Webb or the next generation of telescopes sees that same kind of atmospheric imbalance somewhere else, that would not be a little maybe. That would be one of the biggest scientific moments in human history, and here's the part that gives this real emotional weight. Earth has been advertising life in its atmosphere for about 2 billion years. For roughly half of our planet's existence, a civilization with our level of technology could have looked at Earth from far away and said, yeah, something biological is happening there, which means if life does the same thing on other worlds and there's no reason to assume Earth is the only biosphere that can alter an atmosphere, then for the first time ever, we actually have a shot at catching it. Not a movie scene, not a grainy UFO story, actual chemistry. We're also still listening for somebody smart enough to cheat. Maybe life is everywhere, but intelligence is rare. Or maybe intelligence isn't rare and we've just been checking the wrong way. That's the whole SETI idea. Don't wait for aliens to land. Listen for technology. A natural radio source like a quasar or hot gas spreads noise broadly across frequencies. A transmitter made by something intelligent looks different. It sits at a narrow point on the radio dial. That's what SETI hunts for. Not little green men whispering in English, just a signal that looks engineered instead of natural. The Allen Telescope Array in California, with dozens of dishes and hopes for many more, was built for exactly that. SETI at home turned millions of ordinary computers into a giant distributed alien search. That part alone is kind of beautiful. Humanity literally crowdsourced listening to the sky, and yes, we've had some moments. The most famous is the WOW signal from 1977, a 72-second burst so striking that Jerry Amon wrote WOW next to the printout. It looked good, it was intense, it wasn't obviously terrestrial interference, and we never found it again. That's the problem. In SETI, one weird event is not enough. You need repetition, you need verification, you need to be able to point, test, and say it's still there. Until then, it's a mystery, not a discovery. Same goes for the other strange candidate signals people still argue about. Interesting, yes. Confirmed, no. The Fermi Paradox is where this all turns dark, because the moment you realize planets are common, chemistry is common, and time is unbelievably abundant, one question starts screaming louder than the rest. Where is everybody? That's the Fermi Paradox, not really a paradox in the strict logic sense, more like a cosmic mood swing. The universe is old, there are absurd numbers of stars, self-replicating systems can, in principle, spread. Signals can travel. Civilizations should have time to rise, expand, leave traces, build megastructures, alter atmospheres, or at the very least accidentally leak something weird into space. And yet we've got nothing definitive. No beacon, no ruins, no traffic, no cosmic hello, just silence. So why? Maybe intelligent life is truly rare. Maybe simple life is common, but the jump to complex multicellular tool using technological civilization is one of the hardest filters in nature. Maybe civilizations destroy themselves. Maybe interstellar travel is too expensive, too slow, too pointless. Maybe advanced species use communication methods we don't understand. Maybe they're not interested in us at all. Maybe they're machines, not biology, and their priorities are so alien that our entire radio age just looks like static from a beehive. Or maybe the scariest answer is the simplest one. Maybe there really isn't anybody nearby because the universe is mostly empty of minds. If we do find intelligence, it might not even be alive the way you think. This is one of the weirdest turns in the whole discussion. We always imagine aliens as biological, eyes, limbs, skin, something vaguely creature-shaped. But think about what happens if a civilization survives long enough. On Earth, we're already talking about advanced machine intelligence. So if you're hearing from something that's thousands, millions, maybe billions of years ahead of us, why assume it's still wet biology at all? Some scientists straight up think the first signal we ever confirm might come from a machine, not a body, not a face, a machine mind or a whole network of them. A civilization that moved past biology because biology is fragile, slow, mortal, and messy. That idea is deeply unsettling because it means the first proof that we're not alone might not feel like meeting a cosmic neighbor. It might feel like bumping into the universe's operating system. And then you've got the other layer, the human layer. Do we even want to shout into the dark before we know what's out there? Stephen Hawking warned against actively messaging unknown civilizations. Others say it's too late anyway. Our radio and television leakage has already been spilling outward for decades. Either way, once this stops being philosophy and becomes contact protocol, the vibes get real tense real fast. So are we alone? Here's the honest answer. We still don't know. And that's not disappointing. That's the crazy part. We are living in the first era in history where this question is moving out of mythology and into measurement. We know planets are everywhere. We know some are rocky. We know some sit in habitable zones. We know there are ocean worlds in our own solar system that may have liquid water, organics, and energy. We know telescopes can read the chemical fingerprints of atmospheres light years away. We know what kind of radio signal would make scientists lose their minds. We know enough now to stop asking this like it's a bedtime thought experiment and start asking it like it's an active investigation. But we also know just enough to be humbled, because every step forward makes the silence louder. Every new planet makes Earth look less unique, but every non-detection makes intelligence look more fragile. Every ocean moon whispers maybe. Every empty sky survey whispers maybe not. That's what makes this question so powerful. It isn't just asking whether aliens exist. It's asking whether life is what the universe naturally does, or whether conscious beings like us are one of the strangest accidents reality ever produced. And maybe the answer comes from Europa's hidden ocean. Maybe it comes from a methane chemistry nobody saw coming on Titan. Maybe it comes from a faint atmospheric fingerprint on a world orbiting a dim red star. Maybe it comes from a signal at one clean spot on the radio dial that repeats and repeats and repeats until nobody can explain it away. Or maybe the answer is harder. Maybe we spend the next century searching and learn that the universe is full of habitable worlds and almost empty of minds. That would be huge too, because either way, this question changes us. If we find life, Earth stops being the only known living world. Biology becomes cosmic. If we find intelligence, history splits in half before contact, after contact, and if we search everywhere and find nothing, then what we've got here becomes even more precious, more fragile, and way more bizarre than most of us have ever let ourselves believe. So yeah, next time you look up at the stars, don't just ask if someone is out there. Ask what it would mean if nobody is.